Hi, I am Robin. So today we will be doing this question, which is from GATE 2023. So it's a question number 49. So before I start the question, so it is from quantum mechanics. The topic is the mainly the angular momentum and the hydrogen atom. So you are given a wave function which certainly looks like one of the hydrogen atom wave functions, close to that. So yeah, so we are asked to select the correct options which represent the eigenvalues of the L square and Lz respectively. So the key point is we are given a very you mean a lot of information in these questions, because you don't have to remember a lot of algebraic step to solve this question. So right, so let's start this. Just I start with giving the brief topics from which this question is. Yeah. So let's start the question. So it is the wave function is given in terms of the xyz as this. So where n can be some normalization constant. Okay. Now the best approach when you have questions like this is to convert where you have to deal with the angular momentum. You should convert the wave function into the spherical polar coordinates. So if you see for this case, let's do it in the spherical polar coordinates, which is x, y, z. So if this is the thing and the projection, this is theta, this is y. So x is r cos phi, sin phi, r cos theta. So right, and if you put it over there, e to the power alpha r square. Okay, so now you are given the information in the question, which is the spherical harmonics. So you can see one of the harmonics, which is cos. You can write your wave function in terms of that harmonic. So let's do that. So it is given that your y 1 0, where the L is 1 and M is 0, you can write it as 3 by 4 pi cos theta. Okay, now the cos theta you can represent in terms of 4 pi by 3 y10. So phi r theta phi is n square root 4 pi by 3, and it is y10, and you can write e power minus r square. The radial part and the angular part you have separated for the wave function. Now if you operate the L square on this, what would you get? Because L square operating on y10 gives you L plus 1 y10. So where L is 1, so this is 2h bar square. So you can see your L square would gives 2h bar square, and if you operate Lz on the phi, which is basically this, you would get mh bar y10, and here your m is 0, so Lz operating on psi would give you 0. So which is very clear now. The correct option for this problem is, if you just select this, yeah, so the problem, the C option is the correct one. So L square is 2h bar square and Lz is 0. So yeah, that was our question. Thank you.